There we are.
Got it. Welcome, one and all, to your South Coast Astronomy and Telescope Club's weekly vlog and podcast, everybody. This is episode 46 for Monday, January 10th through the 16th. Second week, I guess, of January in 2022, and 6 more programs, gentlemen. We will have reached a year. It's the SBAU Astro Hour for Santa Barbara Astronomical Unit, done live each and every Monday morning from our man caves and computer dens, covering news and launches and astrophysics. And this week, there's a new comet in the sky to replace Leonard. There's Hydra, the largest constellation. We're going to check out the evening sky, including the first quarter moon, and give you the latest we know on what seems to be a very successful launch of the James Webb Space Telescope, JWST. Let's meet the gang, shall we? The brain trust of Santa Barbara's longtime astronomy and telescope club. President Jerry Wilson, how are you, sir?
Good morning. Good morning.
Had a grand time at our board meeting, our second of the new year, online over the weekend. Jerry's married to Pat Forgy, and she showed up online too. That should be a habit for the ladies. Let's go to Chuck McPartland, outreach coordinator, doing as much.
Hello.
Nowadays, his outreach involves a bunch of cats. It's InReach, actually, and his wife joined him. He's also married to a Pat. We have the most incredible webmaster and technical wizard to run these Zoom meetings, former President Tom Totten. He's got our logo behind him on my screen, upper left. And join us at the bottom of my screen, suddenly flooding my house with the incredible smell of freshly baked sourdough bread, Tom Whittemore, former science instructor out at Westmont College.
You got quite a nose. You got quite a nose.
It just comes with you, my friend. We've all had your bread. It's absolutely incredible. Shall we do, let me pass a sad note, and I may pass this on to you, Chuck. Jiri, Dr. Jiri, J-I-R-I, what's his last name, has passed away?
Yuri Polivka. He was,
Yuri.
he was a radio telescope guy. He had worked on some of the big arrays down in Mexico, and he was from Czechoslovakia, and he was a member of the club for quite a while. And he was into radio telescopes. He actually had kits you could get to make a radio telescope. So I've got one of those that I use sometimes at outreaches when it's not dark. And
big dish.
No, it's not very big. It's made from a wok dish. You know, it's maybe a foot across or a foot and a half across. And so he also donated a radio telescope to the museum. And then he had to move back to Czechoslovakia for a while, and then he moved to Missouri to be near the family. Oh, there's a picture of him on the right. He did a video with the Astronomical League, I believe it was. So he's the lower one there. There's Yuri.
Okay.
And so he was a really jolly, friendly, enthusiastic guy, but he unfortunately had a massive heart attack over the holidays, and he's gone.
That's in there?
That's him.
That's the yeah.
Wish I'd known the man. Well, he'll be missed. His wife, Helena, said he died, I guess, of a heart attack last week of the year, Wednesday, December 29th. Happens from time to time. We also have the note from our benevolent benefactor. The Museum of Natural History is closed down for 2 weeks for safety reasons for their guests, their staff, and their volunteers starting last Friday. I guess that means it'll reopen a week from this coming Friday. We have a planned meeting online for about 3.5 weeks away on the 4th of February. That's Friday, as we used to meet at Farron Hall on the museum grounds. Now we're going to be online. Speakers will be our president, Jerry, and our outreach coordinator, Chuck, and Chrissy Cook, who helped launch the Girl Scouts Astronomy Club for the kids. Talked to our board a couple of years ago. Will also be on screen for 3 minutes. Number 3. How many? You're doing 20 minutes, I guess, right? That works out a lot better than 15. Give you 15, you'll go. Never mind. Who's joining us? Bruce?
Yes. Hello.
How are you, Bruce? Let's introduce this gentleman to everybody. Bruce Murdoch, longtime acting member. Also happens to be president of the Santa Barbara Theater Organ Society, which is also, I guess, sort of shut down due to COVID. His wife is Bonnie. Want to make sure everybody's wives are credited. Tom Whittemore is married to lovely Maureen, and Tom Totten's wife is Cezanne. Be nice to have, all the married ones with their ladies sitting right next to them.
Let me just add to your comment about the February 4th meeting that will be Friday evening at 7:30.
7:30.
Yes.
And I guess the details will go on SBAU.org as to whether it's a webinar, Zoom. Certainly.
I think well, yes, we haven't just completely decided yet.
Webinars
Yes, Zoom.
Okay. Well, we're getting it down. And thank you to the museum for letting us use their account. I mentioned we were going to talk about some things. I'd like to save the James Webb for last and get all these other items out of the way, gentlemen. Oh, we got some sillies. Shall we go to the silly stuff? Starting with the early Jerry forwarded emails. We don't want to do the bat mask. Throw up the bat mask just once. See who gets it. Because there are people who will order this. I think it was affordable. What was it, $45 or something?
It was like $2.50, I think.
$2.50. What was it? There it is. Okay, that's a bat with stripes.
It's a true Batinoff mask.
Is it round or is this?
No, it's round. It's on the end of your telescope.
Oh, it's on the telescope. It's not for wearing?
No. This is to help you. It's an aid to help you focus, but they've added the Batman logo to it.
Oh, that's what I didn't understand. Farpoint Special Edition Bat Mask.
Yeah.
What do we got going here?
It's a Batinov mask, so they're making a little bit of a pun out of the normal terminology for it.
Well, I'm sure somebody.
I don't think it would work all that well.
Probably not.
A normal one would work better, I'm sure.
Yeah.
Batman people are crazy about bat masks, and so shall we go to the silly of the week? The past 7 days, President Jerry sent us careful there with the Earth and Moon talking to each other, about to celebrate the new year. And the Moon is clutching an unopened bottle of champagne, celebrating New Year's. Earth says, hey, careful with that. Last time, we assume uncorking it, you wiped out my dinosaurs. Crying out loud.
6 mile wide cork, huh?
That's how it happened. We also have, you know what? There's a James Webb Telescope funny that if you can find that, let me see what it says here. Astronomy fact, the James Webb Telescope.
Sunshield. The Sunshield.
Sunshield. Can't read my own writing. Is to protect the sun and the earth from its powerful flash. It just says, okay, universe, smile. That's the reason. Look at that. Hasn't even gotten into its Lagrange point yet, and they're making cartoons about it. Now, the latest two arrivals, Tom Totten, titled I Knew It and Electrons. Let's do the I Knew It one first. Back at the very beginning, right before the Big Bang, God is shown having taken delivery on one big instant universe pack. Now you got the wrong one. Shall I do this one or?
There's electrons there. Let's see.
Yeah, I got a negative feeling about this one.
Okay, here it is. God is checking it out just like most of us did on New Year, on Christmas Eve when we had kids. Okay, let's see here. Pull handle A from bundle B and the item will expand. It's like a self-inflating rubber raft. That's how we got the expanding universe. Okay, I'll go to the other one with our president inside. We'll take that down. Electrons. We take you inside a particle physics lab where two scientists are standing at the blackboard, one of them making diagrams of atoms complete with particles. And the other one says to our president, I don't know about you, Jerry, but I'm feeling a lot of negative energy in this room. Sounds kind of like an astrologer. That's how they talk, isn't it? Energy. Okay. Tom Whittemore used to know the joke about the hydrogen atom that was said I'm positive. How does that work? Remember that?
Yeah, it said two hydrogen atoms walking down the street. Okay, and then one of them says, oh, I think I lost an electron. And it's, did you really? And he says, yes, I'm positive.
Science humor, ladies and gentlemen.
Okay.
All right.
We've driven our audience away.
Real quickly, Telescope Workshop is tomorrow night, right? 7:30 to 9. And SBAU.org stands for Santa Barbara Astronomical Unit.org, but use the acronym and you'll find out everything you need to know. Shall we go out into
And I just want to mention, Ron, that Jim Williams is watching on YouTube. So he's left a comment saying he was sorry to hear about Jiri passing away.
Oh, he knew him. Jim Thompson.
Yeah, a lot of us did.
Okay.
Oh, yeah.
I think I've met him. I saw him on the bottom of the screen, glasses, whatever. We all wear glasses. What am I saying? Shall we learn about the evening sky this week and end up with the moon in a quarter phase, first quarter? Let's do the moon first.
Actually, it's just past first quarter already.
Yeah.
That's right.
It's
Right.
even
Right.
past it. You get these out of
It was
astronomy
first quarter last night.
That's right.
Okay. So did you look at the highlands? Anybody focus on the cooled lava, the dark areas?
It was kind of hard to see the moon through the clouds,
Oh, is it really?
thin clouds.
Yeah. Well,
I was out taking some pictures for Jürgen. Jürgen wanted to know, he's really getting into cell phone cameras.
Hmm.
And so
Really?
I plopped my cell phone onto the AP and took some pictures of the moon for him. And he's, trying to figure out what's a good camera and what isn't.
Well, that brings up part 2 of your hooking up your smartphone, Jerry, maybe later on or at some point. Did we do the
That
whole?
was last week we did that.
Mhm.
You did all of it.
Yeah, he can reference the last broadcast we did or whatever these are called.
But you did the whole thing. You didn't do it. It
Yeah.
doesn't need to be a second part. Okay. Anything more
He
on the
can
moon?
also send questions to us. We'll respond in emails if he has questions that we didn't cover.
Sure. And Tom,
The reason the smartphones work well is that the eyepieces on telescopes are designed to focus the light to a circle the size of your pupil.
Yeah.
Because
Is that
light
right?
outside that doesn't help you. And that's about the size of the aperture on smartphones.
Mhm.
well, have you ever taken a picture, Bruce, using a smartphone held up to your eyepiece?
No, I have an adapter that'll do that, but I just have an adapter that puts my camera becomes the eyepiece for the scope.
I
Yeah,
see.
Pull the eyepiece out and put an adapter on the camera and put the camera
I've
in.
taken pictures as you described by holding the camera over the eyepiece. And I get about one good shot out of every 3 pictures I take.
Yeah, you need a thing that can center it accurately and
Right.
hold it there.
That was before I knew you had devices that would hold it there.
Right.
Huh.
I can put up a
Okay.
picture of what
You were saying?
I can put up one of the pictures I got for Jürgen just to give people an idea.
Of how it
Of
looks.
course, I didn't frame it very well. But let's see. Is it okay if I share a screen here?
Yeah, well,
Yes.
it's okay with me.
Actually, let me find a better one
You could zoom in on it or something.
What's it a picture of, Chuck?
of the moon.
Oh,
Okay, yeah. This is a better one. Okay, share screen. Okay, it's not seeing my window
uh-oh.
when I say share screen.
Well,
Let
take
me try this. Allow zoom. Okay, so okay. No, I can't do it. Never mind.
All right.
Okay. Well, I'm sure it would have been a great picture.
Yeah, I've got an upgraded. Upgraded my operating system, and the security settings don't let me do this unless I go set a bunch of things. So
All
never
right.
mind.
Well, shall we talk about what's up there on the quarter soon to be half moon? I guess that's the craters. Terminator is between night and day,
Mhm.
and the northern hemisphere is where the Maris are, and what's down in the southern
If you
part.
put up the picture, not that picture, we'll get to that, but if you put up the picture of the exact quarter moon that I had in the
Oh, there we go.
That's it. You can see Ptolemaeus in the center of the picture, and it's right on the, yeah, that's it. It's right on the Terminator, and that has got a lava floor that's slightly bowed up with a hill, and when it's on the Terminator like this, you can see real subtle shadings in the floor like that. There's compression ridges, and you see the left top half of the crater is dark, And the lower right is light. That's because you're seeing the slope of the crater.
Craters like Albatignius have the center of peak in them too.
Yeah, yeah. So those two craters right there were one of the first things I ever looked at on the moon when I built a 6-inch telescope back in the late 50s for a high school project.
And if you want to plan what you're going to see that takes into account libration and the phase and everything, the Goddard Space Flight Center in Maryland, NASA GSFC, has a visualization studio where you can go and set the date and time in universal coordinated time, and it will show you exactly what you're going to see on the moon. And it looks very much like this image.
But this was last night. It was the first quarter.
Yeah. Oh, you took this picture?
No, I took this picture off the internet.
Oh, okay. But where is Hipparchus and Albategnius?
Oh, next picture.
Oh, they're not part of what we're seeing in the middle there. They're in this picture. Those are craters.
Yeah.
Okay. Just south of the lunar equator.
Yeah, this is the southern part of the moon where Copernicus is.
Yeah.
Uh-huh.
Well, this is central.
Yeah.
I think you're thinking of Tycho.
Oh, yeah. Okay.
So this moon is reversed from what you see in the telescope. This is the moon as it actually appears to the naked eye.
But we call this a quarter, not a half, because that's absolutely just a quarter of the whole surface of the moon, including the other side we never see, right?
Yeah, and it's a quarter of the way around its orbit.
So there's no such thing as a half moon, then, is there?
Well,
That's
the full moon is technically the half moon.
Yeah.
And the new moon is technically a half moon. So
All right, got it. You know, there was a great picture. Is there any way we can jump to the ISS photograph of the crescent moon taken by the ISS, Tom Totten? This will insert that in here. Do you have that on the screen from Jerry sent it? It's among his sillies and cartoons, but it's definitely a serious.
Yeah, but it wasn't part of the talking points for this show.
Oh, all right. Well,
but we can go there if you can find it.
Yeah, I can find it. Yeah.
It looked pretty good. So since we're talking about the moon, I'm not sure. I've never seen a picture of the moon, I don't think, taken by the ISS. Coming?
Here, just a second.
Like to share as much of this stuff as we can. The curvature of the Earth with the crescent moon above the curved horizon. There it is. Look at that.
Mm-hmm.
All we need is a Bruce Murdoch green flash.
That sun has set.
Okay. All right. Thank you very much for that.
Beautiful picture, though.
Mhm.
Shall we go to the early evening sky and bring in maybe any late occultations our outreach coordinator may have done, since it mentions asteroid 7 Iris? Have you ever occulted that, Chuck?
No.
All right.
In fact, I'm dead in the water right now because my video capture system failed. So,
Oh,
Because of your new operating system?
well, that's part of it. I have 2 laptops, one that I was running legacy stuff on, but it's 10 years old and it went belly up. And with the new operating system, the drivers for the digitizer have to be 64-bit, and the digitizer people have not made 64-bit drivers. So I'm dead until I ordered a new digitizer from Canada that hopefully will be here in a week or so.
All of my equipment in my electronics lab is connected together on what's called a IEEE bus. And all the software that I've written is on the computer I have runs Windows XP. Because everything works. I have no need for it. It is not hooking up to the internet. And if it ain't broke, don't fix it.
That's why I had the 10-year-old. That's why I was using the 10-year-old laptop.
Yeah.
Okay.
Well, mine's only 5 years old, and all of my stuff is Windows 7.
This my main computer, and my wife's computer is Windows 7.
Yeah.
but Bruce,
64-bit. Yeah.
Bruce, you and Tom Whittemore have never gotten excited about going out at night and doing what Chuck does with his finding asteroids, occulting stars.
Oh yeah. Well, last Friday, Charles Schuler and myself were out. We saw the comet Borrelly and Leonard. They're very
Okay,
faint.
we're going to go there in a few minutes.
Yeah.
Leonard gets replaced by Borrelly, but asteroid 7 Iris reaching opposition, visible all night long. One thing I'm learning about this program is that a lot of those dots up there are asteroids, but they go different places than stars, don't they? They're moving.
Well, most aren't visible to the naked eye either, although this one is getting toward the threshold.
It is a point, let's see, what a magnitude 5.8.
Yeah, that's not visible to the eye from Goleta here.
Yeah.
Okay, so you can't see them. All right. It's in East Gemini rising as the sun sets. You first find Lambda Geminorum and his orchestra, which shines at magnitude 3.6 and 4.5 degrees east of it, reflected light. There it is. Wow. Okay. Has it ever occulted anything, McPartland?
Oh, I'm sure it has. Just not one that I've tried.
Oh, I see.
It's pretty large for it to get an image like this from ESA or Hubble, whoever did this.
You're going to talk for 15 minutes about your occulting on the night of the 4th of February, are you not?
Yeah.
With pictures?
Yeah.
Okay, we'll look forward to that. All right.
Okay, this is from the Very Large Telescope, so this is from ESA, yeah.
It says asteroid 7 Iris. Does that mean there were 6 of them before this? This 7th?
Yeah.
Because
Seventh one discovered.
I'll be damned. Interesting. We named it Iris. Okay. Also in the evening, not to be missed, encounter between Mercury and Saturn. Did we get any pictures of that? 2 or 3.4 degrees apart. How in the world can they do 0.4 degrees? Why don't they just round that off to 3.5 degrees apart? I guess you've got incredible devices, measuring tools on your instruments.
Well, you can go down to minutes of arc.
Is that
That's
right?
60 minutes per degree.
The minutes and even the seconds are all part of.
Oh yeah, right.
Okay. Well, Mercury and Saturn are coming together. North Capricorn, Mercury is at magnitude what? 1? Brighter than Saturn? Magnitude 0.7 for the rings. Wait a minute.
Yeah, we saw it a few nights ago in binoculars.
Did you?
In the haze, yeah.
Okay. And they're going to pass each
Mercury.
other? Actually, Mercury's going to stop and go into retrograde, isn't it?
Mm-hmm. Yeah, it's in the haze. You need binoculars to see it. And we saw it easily.
Okay. It's 8 arc seconds, just 29% lit. Will come to a halt and reverse course and pull away from Saturn.
Mm-hmm.
Okay.
Yeah, right now it's still moving upper left.
Fantastic.
It'll flip.
Don't have anything to say about Venus. I guess
No,
we're
that's
going to launch there.
too
I
close
guess
to the sun.
eventually.
It's getting ready to become a morning object.
Oh, it is.
Chuck, do you know when it will be a morning object?
No, I haven't been paying attention to that, but it won't take long.
Yeah.
There are several photos of it. If you go to spaceweather.com, there are photos that people are taking by blocking the sun with a building or with clouds. And it's quite a slim crescent, and it's a crescent over something like 273 degrees of its circumference. Wow. So it's almost a circle of light, which only happens when it's kind of directly away from the sun from us. But yeah, here's a picture. You can see it in the morning sky, and they have a whole gallery of Venus photos too. So you can see it's quite large.
Oh yeah.
Okay, well, is it NASA that's going to launch toward Venus this year or next?
I think there's NASA and the European Space Agency both.
Are they going to land?
No.
They're not going to land. They're just going to orbit. Russia gave up, and I just recently learned they had a bunch of Veneras. Only 1 or 2 of them made it to the surface. Didn't last long. Everything else exploded or
Well, that's neat. Huh?
burned up. Look at that. Okay.
It's not good.
Interesting. Shall we do the new comet? Somebody mentioned, who was it? You, Bruce, Tom Whittemore?
Both, yeah.
Borrelly.
No, I have not seen it. I saw Leonard weeks ago.
Well, it's 19P, whatever that means, Borrelly.
19P means it's the 19th comet that they found an orbit for that's periodic.
Okay. It's located between 2 stars, Difta, magnitude 2, and Iota Ceti, magnitude 3.6, out in Ceres the whale. And Borrelly came out of nowhere. I guess.
Yeah.
Well, no,
I
it didn't
saw-
come out of
Yeah.
nowhere. It's just that it's getting bright now. Brighter,
Right.
not really bright.
Well, in one of the many animated trips of the James Webb that I get on YouTube, I saw one the other day showing it passing Halley's. Is Halley's out there?
Halley's Comet is out beyond Uranus right now.
Yeah.
Okay, well, it passed it. Maybe from our vantage point, it
No.
was there on the screen. I don't.
Oh, well, it might have passed the point in the sky where it is.
Yeah, that's what I mean. And it made me think, well, is it coming back? It goes away for
It
some.
would take a pretty big telescope to take a picture of Halley's Comet right now.
Would it really? Well,
Yeah, I last saw it for my last time in 1986 in Tucson, Arizona. It was naked eye.
there it is.
No, this
Shaped
is
like-
this is borrelly.
Yeah, bowling
Okay.
pin, 5 miles long, shaped like a pin. Does that mean it's two small ones or smaller than it is now that came together and kind of
Yeah,
merged?
probably it's a lot of lobe structures like that out in the Kuiper belt from
Huh.
low speed collisions.
Well, where is it going? Where is it, and where is it gone around the sun yet, or is it heading in?
I'm not sure if it's at perihelion yet, so it's heading in.
If it's brightening, it's heading in. So, but this picture you're showing was taken by Deep Space One. This is the third comet visited by a spacecraft. And this picture was taken in 2001.
There it is. You're right. Wow.
It's 5 miles long.
Well, here's something I'm going to quote from your talking points, Jerry, that I kind of wanted explanation. This is interesting. Quote, look for its slightly out of round gray cotton ball-like glow, some 6 degrees northwest of Diptha. Cotton glow does it not
That's
have
another euphemism for faint fuzzy.
okay. But we're
And
looking at,
Dipta is also known as Deneb Kaitos for people who are looking on
Right.
planetarium programs.
Yeah, thanks, Chuck. It, means, of course, the tail of the beast. And Botan Kaitos is the belly of the beast.
ooh, and the beast is a whale?
Yeah.
Yes, sea monster. Mhm.
That has nothing to do with the Pinocchio story, I guess.
Oh, no.
It's Andromeda and
Andromeda.
Perseus.
Oh, Andromeda's in Cetus the whale?
No, Cetus was the sea monster coming to eat Andromeda.
Right.
Oh, I see. Andromeda, we tacked on the nearby galaxy. All right. And Leonard's gone away, or it's fading? It's heading
No,
back
it's
out?
gone.
heading
It's
south.
gone. Yeah, it's gone south.
Yeah.
Okay. Assume you gentlemen.
We
got-
only caught it once before it did that here from the house. Many weeks ago now.
Okay. So
Binoculars.
What's the date on that finder chart you showed for Borrelly? That doesn't look like today, or does it?
Let's see. Here's a tracker.
There's Borrelly around dead center.
Hard to see on this thing.
It says live position and date.
Huh,
It says the perihelion is in April.
okay.
April.
So that's as close as it's gonna get to the sun.
Huh.
Yeah, this is a live tracker. So, if your finder chart is for tonight, it's got a little ways to move yet.
Yeah,
One of the things I learned is always half a dozen comets in the sky at any one time.
oh, there's more than that.
Yeah, it just depends on the size of your telescope. Same with supernovas. You have
Yes.
a big enough telescope, you can see thousands in a night.
Is that right?
Mhm.
Do you suppose we have a man-made comet going around the sun called the Parker Probe? Is that going to come back?
I don't think it's emitting volatiles to have a tail yet,
Yeah.
but if it stays close to the sun, it'll develop one.
But it comes within 3 million miles. Do any of these comets get that close?
Oh, yeah,
Yeah.
some comets
Oh, yeah.
crash into the sun.
Well, then they don't come back.
No, some of them don't come back even though they don't crash into the sun. They just get too near.
But we're not going to get the Parker Probe back, though. It's going to stay there.
Yeah.
orbit.
Well, it's in a widely elliptical orbit, so it doesn't spend a lot of time getting heated
Yeah.
up. So it comes back to our vicinity every once in a while.
Huh. Well, there's got to be comets that lose it all, even if they don't go into the sun. They get so close that there's so much heat, it just steams everything away. I'm imagining
Yep,
that happens.
it
Wow.
boils them off.
Then they become asteroids?
Or they just totally volatilize
Yeah.
or
Okay.
hit the sun. I mean, there are people that just make it a pastime to watch the SOHO images or some of the other sun watching satellites, to watch those images and discover new comets that just come in and disappear, basically because they get eaten up.
But now asteroids, whether they be Trojans in Jupiter's orbit or in between Mars and Jupiter, they rarely leave their orbit and become sort of a pseudo comet. They don't have enough water on board, do they, to make a tail, right?
Well, some of them do. There are asteroids in the asteroid belt that are active and have a coma. They don't really have a tail that's visible easily. I'm sure you could detect one.
But the comets come mostly from Kuiper Belt or Oort cloud, and they have water on board.
Yeah.
Why do you suppose all those rocks out there have water, and the asteroids have been shed of their water over the years? Do you suppose?
Not
Well,
necessarily. Go ahead.
Well, they're near the what's called the freeze line in the solar system, where it got hot enough to drive a lot of the volatiles away. So they still may have them interior to them, and that's why we occasionally see active asteroids with a coma.
The freeze line.
Yes. Ceres is an asteroid that is in the asteroid belt, and it has water approaching, believed to be approaching that of Earth. So it has a tremendous amount of water inside of it. But it doesn't make a tail because it's not readily accessible to the heated surface.
I got you. But they can vary in size from just boulder to city size, can't they?
Sand to city, yeah.
See. Does anybody know who Mr. Borrelly was? And is this an old?
That was in 1840, I think, that he discovered it.
Oh, okay.
If I remember right.
Well, shall we go forward and talk about the Russian guy, Friedrich Struve?
And I think we need to go talk about James Webb before we run out of time.
Well, we got half an hour. Okay, you're on.
Okay.
I didn't write anything down except that umbra, the shadow from
The umbra. Yeah, the first picture I supplied there shows a diagram of the sun and the Earth, and to show the Earth's shadow in space.
Mhm.
And you see the sun is bigger, of course, so the Earth's shadow eventually comes to a point. There's still shadow. So if you were at that point and you were looking back at the Earth, you would see a total eclipse of the sun from that one point. But if you moved off of it slightly, then it would be a partial eclipse. You'd still get part of the sun shaded, but you wouldn't get the whole sun shaded.
right.
So the Earth's shadow is roughly 870,000 miles long. From the Earth to that point is just under about 200,000 miles under, or wait, 130,000 miles under a million miles. So if the James Webb is going to sit at the L2 point out there, it's outside of the Earth's shadow.
Mhm.
So it's about,
Jerry,
It's still in
Jerry,
the penumbra, probably.
yes, I was just going there. Thank you.
Okay.
Jerry, I was looking at the sun diameter being 865,000 miles. It's funny that's almost the same as the length of the umbra.
That is the length of the umbra.
But in this
Well,
diagram, that's the diameter of the sun.
Yeah.
Right.
And
Quite a
the
million miles.
umbra length is about the same. That's pretty
Oh,
strange.
pure coincidence. So anyway, the next diagram shows the Hubble as it orbits the Earth,
Mhm.
which is about 350,000 or 354 miles above the surface, and then inside the orbit of the Moon. And the L2 point is about 930,000 miles out, where Hubble or Webb is going to be. So it's outside of the umbra of the Earth. It's still in the penumbra. That's correct.
Right.
But you see the Hubble, when it goes around, it's partially in the shadow, it's partially exposed to sunlight. So the Webb is going to be looking at very long wavelength infrared. So we don't want to look at the Moon or the Earth's sunlit side. They're very bright in the infrared. So we want to keep it about the same size, the same temperature, or just look at block as much heat as possible is the best way to say it. So we want to keep it oriented. So it's always, the sun is always in one distance or one direction away. It gives us the other sky, part of the sky, to always look in. We don't have to interrupt the viewing periods when we're in the night side of the planet. So the other one that I have down there, in the case of the L2, and this diagram is a little confusing to me. In looking at it in detail after I put it up there, the idea is that at the L2, at these Lagrange points, the gravitational pull of the Earth and the sun are the same, but they don't always cancel out. Some of them in the L1 point, something placed at the L1 point would be equally pulled by the Earth and the sun. And if you put something there and it drifted off the L1 point, then it would start accelerating toward that object. But the L2 point is different. The sun and the Earth gravity is the same there, but they add to each other. And that's the reason that they want to use the L2 point, because gravity is stronger there. And the reason is because if you want to put something, as we do, you want to put something that always orbits the sun in formation with the Earth. If you go out to the L2 point, when you go to an orbit that has a bigger dimension, you're going to a higher energy orbit, but a slower orbit. So the Earth would simply pass up the James Webb and leave it behind. So it would no longer be in one direction, and pretty soon the sun and the moon, Earth, would be separated, and you'd be looking at the both. You have to dodge the heat signature of them. So you want to fly in formation. And so the added gravity at the L2 point gives you that extra pull. In order to be in orbit at the L2 point, it has to travel around at a higher speed than it would if it were simply at that distance from the sun. So the Earth's pull on it gives it an extra boost of energy that lets it fly in formation with the Earth. Does that make sense to you?
It wouldn't work if the Webb were another 100,000, 200,000 miles out, or twice as far. It would suddenly.
The orbital dynamics would be different. You have to, if you were farther out, then the Earth would pass it up. And so it couldn't fly always on the dark side of the Earth.
Okay.
And how do they station keep?
They station keep, the thing will orbit there. That's just in its orbit. Like, how do you keep an orbit? When you put something in orbit, like the ISS, it goes around the Earth every, 90 minutes.
90 minutes, yeah.
Yeah, so that station, that's on station, it's in that orbit. So
this thing orbits, the James Webb's orbits L2 though.
Yeah, the James Webb orbit is at L2, but it orbits the sun, and it orbits the sun with the Earth's aid of the extra gravity from the Earth. It orbits the sun at a higher orbital speed than it would if it was just that distance from the sun.
But
so they don't have to do anything to keep it there.
Yes, they don't, but they do. And we'll get to that in a minute.
Okay, that's what was leading up to that also.
Yeah.
They are orbiting around the L2 point, right. It sort of Correct. In the L2 zone.
Right.
Right. Oh. So, and they'll be in orbit. The reason that I'm confused by this diagram, I thought it showed what I wanted when I picked it, but what is the vertical axis here? It looks like it's gravitational potential. And
somebody objects to what you're saying, Jerry. Sorry.
My phone. The gravitational potential. So as the potential gets stronger, the potential goes down deep. But then it wouldn't rise up to L3 and then drop down again, because as you get farther away from the sun, the gravity is not getting stronger. It doesn't present gravity strength, because as you go toward the sun, gravity would be stronger, not weaker. So this is a very confusing diagram for me. It must be something I missed in the description of the diagram.
I have a couple questions.
Yeah, go ahead.
A question from Tim Crawford. He says, is the L2 point also a good place to stay cooler?
It sort of is, but that's why it has sun shields on it. The hot objects in your life, if you're there at the L2 point, the backside of the Earth and the sun, partially hidden behind the Earth, you're looking at the darker side of them. So there's a lower heat signature from them, but it's not a no heat signature. So you have to have these multi-layer shields that.
In order for the Earth to be a shield for the James Webb, it would have to be at the location of the moon. For the same reason we get lunar eclipses.
Yes, that's right. But it's much farther away. This is.
I understand. So you can't. It needs a shield.
Yeah, that's right. It needs a shield because you're outside. That's why I went over the length of the umbra. You're outside of the Earth's darker umbra, but you're inside the Earth's penumbra. So you do get some heat shielding.
And the whole reason it needs to not be in the umbra is because it's solar powered.
Right.
If you were to take away the Earth at this point and it's going that speed in its new orbit, it would fly out of the solar system slowly.
It would fly to a higher orbit. It would immediately adopt an elliptical orbit that had the L2 point as one of the points of its orbit. So we'll come back to that point again. But that's if you snapped your fingers and the Earth disappeared. But it's not likely to happen.
Does this diagram show where it is? It's only halfway?
No, that diagram, the one he has up on the screen.
You can see it's 70% of the way there.
Yeah.
Okay. That's what I was thinking. And the moon is off. It should be a quarter of the way.
Mm-hmm.
But everything is unfolded, hasn't it? Everything's in place.
It's now in its configuration. It's fully deployed and set up. The remainder of the time period, when it goes to insertion around the L2 point, it's going to calibrate itself. It's going to jiggle all the mirrors to get in focus. It's going to cool down very low temperatures, get ready and take some first pictures by the time it gets there.
And what's confusing, Ron, what's confusing about that diagram is that's a time diagram. So that's the number of days. And it's slowing down as the sun is pulling on it as it goes out there because it's not being actively thrusted right now. And so the distance and the time, doesn't seem to jive there. But this is a time diagram.
Well, I remember when
Tom clicks on distance, it'll probably change that view. If he comes down below the line and clicks on distance on the right.
Right.
Oh, yeah.
Okay, see, now you can see it's 70% of the way there.
Okay, but speaking of time, we all remember the Apollo launches took about 4 days, did they not? 3.5 to get to the moon, which is a quarter of this distance.
3 days.
3 days. And yet this has been up since what, mid-December or late about
Christmas.
Christmas. Okay.
Jingle bells, jingle bells.
Yeah.
So the other thing
Jerry,
yes?
Jerry, let me ask a question. Why is it slowing down? Is it the gravity pull of the Earth is slowing it down? Is that what's going on?
Earth and the sun.
The sun. The sun
Plus the
sucks.
sun.
When you put something in an orbit, like for example, ISS, which is I think 250 miles up roughly, and it has an orbit that goes around in 90 minutes. If you put it in a higher orbit, then it will take longer to go around. So it's in a slower orbit, but it's not slowing down.
Okay.
Well, it's slowing down in its trajectory out there.
Well, yeah, because of gravity is pulling on it.
Yeah.
Yeah, just like all objects slow down as they climb up in altitude. Now, there will be a burn to lose a lot of speed when it gets to the L2 point because they're going to do an orbital insertion. They're going to orbit the L2 point because the L2 point represents a high gravity source. There's no mass there to create it. It's the vector sum of the gravitational pull of the Earth and the sun. So, but there is a gravitational peak there. And so you can orbit it.
And it's way past the umbra, right?
It's out of the Earth's darkest part of its shadow, but
Right.
it's not out of the Earth's shadow completely because there's the penumbra that it's still in.
So it'll be
I
in
thought
two
that the reaction wheels were that they didn't like to use chemical rockets because the rocket products ends up condensing on the mirror.
That's correct. And what they're going to do is they're going to insert it in orbit around the L2 point, and then they will use reaction wheels to do the pointing in that orbit around the L2.
So what happens to the effluent from the rockets? You know, the exhaust from the rockets.
Yeah, it's only a one-time burn. Then
They're going fast enough that they leave the combustion products behind.
Yeah, you spit the exhaust out at very high speed and it goes away. It doesn't come back on the thing on the spacecraft.
And the orifices for the engine are probably on the other side of the Sunshield too to help.
Yeah.
Okay.
So it uses the reaction. It has two things to sense its position and orientation. One, as Bruce is aware, is a hemispherical resonating gyroscope, which we used quite a bit on our spacecrafts when I was at SBRC and Santa Barbara Remote Sensing. So that it's basically that resonating gyro is very, very sensitive, and it's basically a wine glass. If you take a wine glass and you lick your finger and you run it around the rim, you get a sound. That's that hemispherical glass hemisphere, and the one on the spacecraft is made out of quartz. If you get that resonator going, that's the resonant frequency of that wine glass. If you suddenly move the wine glass and you have real sensitive ears, you can hear the tone change on the sound as the wine glass moves. That's the principle of the resonating gyroscope. And it has sensors around it. It's activated to oscillate at its resonant frequency, but the resonant frequency changes slightly with motion of the sensor. And that's an extremely sensitive, it's the most sensitive I know of. It beats when we were picking them, it beat the optical gyroscopes that we were looking at. Yeah, lasers.
Well, this is also, I believe, a force balance gyro. So they always try to keep the pattern in the same place. It wants to move when they rotate the gyro, but they electrically move it back, and that's a very precise.
Yeah, that feedback is how they measure the resonance drift. So
Jerry,
one more point. And so to move it, to point the thing, once it's in orbit around the L2, in order to point it, it has some spinning massive little wheels, I believe 6 of them, 2 for each axis. And it pushes on those. They have a moment of angular momentum that you can't twist, but you can easily, you have to add energy to do it. So you push on these things, and that's the thing that orients the telescope.
Oh. Tom Totten, what did you want to ask?
I was going to ask about, do they have to constantly give a signal to that gyroscope to do they just get it going down on Earth, and then when they shoot up in space?
There are metallization on both sides of the wine glass. The wine glass actually has the stem going out the opposite way that a normal wine glass does.
Yeah, it's an upside down wine glass.
Right, and or inside out.
Inside, right.
But on one side of the wine glass, they've got metallization that is part of the forcer system that always maintains a constant amplitude. And then on the other side is where all the pickoffs are.
Mm-hmm. So they have to keep that finger on the wine glass at your party when you go around the rim. They have to keep that finger moving all the time they want the gyroscope to operate. And what Bruce described is the electronic version of that finger running around, causing the resonance, causing the vibration.
I thought one of you gentlemen wrote in your email exchange that there were no moving parts.
Well, there's no parts that move, or this. That's technically not a moving part, I guess. Well, I guess technically it is, but there's no bearings that have to be moved against.
What's moving are the atoms in the crystal.
Yeah.
Does it look like a wine glass? Is it crystal?
Well, a wine glass has the stem coming out the opposite side from where you drink.
Yeah.
This one has a stem coming out the same side.
Yeah.
Huh.
But it's quartz crystal, so it would look like a wine glass.
Yeah. But it's coated with metal and electrodes, and it takes a little bit of electricity to keep it operating and to run the sensors. But it gets that from the solar panels. That's why you don't want to be parked in the dark, dense shadow of the Earth, because you need the solar panels. The other advantage of being at the L2 point is you have direct communication all the time to the satellite. It's always in the same place. In contrast, the Spitzer Space Telescope, which is another infrared telescope, is in its own orbit around the sun and is drifting away from the Earth. It's more than 100 million kilometers or 60 million miles away from the Earth right now. And eventually it will take it to the other side of the sun. And when that happens, and we no longer can communicate with Spitzer, that means its mission it's at the end of life of its mission. It's over.
It looks like it says it retired on 2020, January 2020 here.
For the main mission.
Ah,
So the Spitzer wasn't orbiting Earth. It was.
But
on
if
its
it
own.
goes around the sun, it's not going to crash into the sun, right? It's going to come back out the other side.
Yeah, but its mission is over.
Okay.
I don't know. I know in cases like that, I know in general, they want because there's so damn many satellites up there, they want satellites to be deorbited when they're done. And I know we put rockets on our satellites, even around Mars and Jupiter and Saturn, for that purpose. You remember we crashed Cassini into Saturn with a special rocket for that purpose. I don't know if they have the same thing on the Webb or the Spitzer. You know, floating around the sun, that might not constitute space junk unless you're very unlucky up there someday.
But it was launched from the Earth, which now defines part of its orbit, right? And it's going to go around the sun. Will it not come back to the? Oh, that's
Yes.
right. The Earth might not be where it comes back to. It'll come
Right.
back across the Earth's orbit.
Right. But eventually, you know, the chances of it being there that the Earth will maybe millions of years in the future, but it could come back to the Earth.
If you were to aim a telescope at the James Webb, all you would see would be that Sunshield, wouldn't you?
Yep.
You
It
probably
actually ought to be pretty bright too.
Yeah, you probably wouldn't resolve it. Depends what size the telescope is. If it were on the moon, you probably couldn't see it. And so being farther away than the moon, you probably will not resolve it, but it'll be a point of light.
But now the Sunshield is going to be behind it, in between us and it. And
That's what you'll see.
yeah, but the telescope itself will have what, like 180-degree range? It can go left, right, forward,
And up and down.
but not backwards toward the Earth and the sun.
No, you can't. They're never going to turn the satellite over to let the sun shine on the telescope.
What would you agree about 180 degrees, about half
Yeah.
of the cosmos
Yeah,
at any one
They
time?
go all the way around there, and you can tip it a bit too with the reaction wheels. And the reaction wheels are going to orient you and then hold you in position when you're at the right line of sight angle.
Wow. How many of those tennis court shaped sized, how many are there? There's several in a
Six.
Five.
Six?
Are there 6? I thought it was 5.
Yeah, I thought it was 5, but there's a bunch.
Yeah.
Well, I guess you could ask the same question of the space station. Have they ever been hit, or do they expect this to happen?
They have moved the space station several times to avoid space junk.
And they have been hit by space junk. There's a hole in the Canadian arm caused by an impact.
Oh, that's right. Yes.
Okay, and this is Mylar or something like Mylar?
Kapton. It's Kapton
Oh,
because of its thermal expansion and contraction characteristics.
and they've unfolded all, how many? 18 hexagonal?
5. Oh,
No,
yeah, right.
Mirror segments. Yeah, the mirror segments are
Right.
unfolded, but they have not been formed into a single surface mirror yet. That's part of the calibration now. They're going to start aligning those segments with each other in detail to get a single image.
Aha, there you go. So it's not automatically in place. They got to fine tune it with some sort of little motors.
Little actuators, little piston things, push-pull things.
Wow.
And it's easier to do with infrared than visible because the wavelength is like 10 to 20 times longer. So the mirror can be 10 to 20 times less accurate than we make our telescope mirrors.
Wow. Then it'll be a year or summer before we get anything back from it.
No, I think their first test pictures will be made within the first few weeks of it arriving at L2.
Really? You know what they're going to take a picture of?
No, I have no idea. Maybe it'll be a test pattern. That Indian head thing used to see on TV late at night in the 50s.
Sermonette.
No, they'll probably look at a bright star, will they not? Because they need an object with which to determine how much to move the mirror.
Yeah, they're going to
kind of look at the image and say, what do I need to make it, not fuzzy.
Yeah.
This part is a little out of your field, gentlemen, but I've always wondered about the radio frequencies they allot for these things. I wonder if they have one or two basic frequencies and they can put a million things on it, just like our cell phones use one frequency. Do you understand how cell phone electronics works?
Sure, they're definitely going to do that. I mean, they're using the deep space network, so they're using the usual space communication frequencies.
Okay.
L-band, yeah.
And that's those three big radio antennas, one in Australia, one in Spain.
I think there's more than three.
Yeah. There's Australia, there's Spain, there's here in California, there's West Virginia, I think. Yeah.
Our friends out in Goleta at the Las Cumbres observatories, that have nothing to do with this, I assume, do they? Oh, probably love to. Look at that. What are we looking at?
Play the video. Let's see.
Yeah, click on that sucker, Tom. Here we go.
Well, that's showing how it stays always oriented to the Earth. That's right. And the wiggling, the lumps in its orbit are because it's going around. There you go.
Yes, it's going around the L2, and you can see the Earth, and it does not cover the sun.
Well, it kind of occults it, just like looking at exoplanets.
Yeah, it is. I think it's a little exaggerated.
Transit.
That's the word, yeah. Oh, okay, that's what that peanut butter shape I was looking at.
Peanut butter shape.
Or a peanut shape, rather.
Mm-hmm.
Peanut butter doesn't particular shape.
It couldn't just sit there and not move at all, just stay out there and not.
That would take a lot of rocket fuel to have it hover in space. It's always in a gravitational field, so it's always going to do some kind of motion in reaction to the gravitational field. And you're going to have to.
As long as they know where it is, they can back it out mathematically when they get the images.
Yeah, that's a field I worked in a lot called line of sight knowledge, LOSK. Is once you figure out where you are, then you can process the data.
Wow. You got a lot of stuff.
Tim Crawford is asking about how they convert the infrared image that they'll get into a visual image for folks. How does that work?
It has a camera sensor in it, a two-dimensional X by Y photo sensor, just like your cell phone camera is. But it's made out of, the real long wavelength stuff is made out of extrinsic silicon. And I believe that the not quite so long wavelength is made out of mercury telluride.
And they get, a series of numbers representing the intensity of the radiation at that point.
On each pixel.
And even though you can't see the infrared light, they can take that number and just, convert it with a palette into something you can see. So.
Wow. Well, the original intent was to check out the distant universe or distant galaxies, and now they're going to add exoplanets within our own galaxy.
Exoplanets were always in the mix.
Oh, they were?
Planets are not as hot as the stars, so they need a sensitive IR telescope to try and see them directly.
Have you heard about another space telescope that has a big, large, round, sunflower-shaped shield that gets sent out away from it? It blocks the distant stars.
Yeah.
That's a proposed mission.
Right.
I said it hasn't happened yet, huh?
No.
Right.
No.
Wow.
I can write a paragraph on it for next week.
Okay. Why don't we?
It's called BOSS or something like that. Big occultation shield.
Well, there's something to be said for planning and repeating and testing and over again. This sucker so far has been successful. Kept holding my breath thinking, uh-oh, something's going to not lock into place.
No, We all held our breath and it worked.
Oh, there it is. Is that the one I was just talking about, Tom?
Yes.
You were awesome. There it is. Big sunflower, and that's going to block the star so they can see the planets in the distance.
Right. This is not to scale.
Yeah, right.
How far from the orbiting telescope will it be, do you suppose? How many?
It has to be pretty far to just block the star and not the planet.
Yeah.
What, do you have a name for that project?
It's something like BOSS, big orbiting or big occulting system.
Oh,
Space system, BOSS.
too bad they couldn't integrate it in with the James Webb, and we'd get some awesome pictures of exoplanets, wouldn't we? We could occult those stars. I think we've run out of time, gentlemen. What are we looking at here? Our MOU? Oh no, JPL.
Yeah.
Aha. Well, we are going to be meeting online again next Monday morning from our dens and computer man caves. And then we're going to have a big, at least a couple hours with some great speeches from Jerry and Chuck and Chrissy Cook on the night of the 4th of February. And exactly 1 month later, we'll have our first speaker, I think a young lady named Lynn Briley. So gentlemen, thank you for number 46. This was awesome. We learned a lot. We're going to start promoting the club and making our way back past this Omicron. Take care of your wives and yourselves. And thank you very much for giving us a fascinating hour of SBAU Astro stuff. Jerry, Chuck, Bruce, Tom, and Tom. We'll see you next Monday morning. Fair enough?
And thanks for Tim and Jim Williams for checking in on YouTube and giving us a little bit of chat stuff.
All right, my friends. Thank you. And we'll see you for number 47 next week.